And this front page is blank for a reason. We'll come back to it later, okay? And it's a short unit. Like we're gonna test probably the day before the break. Okay, so next week Wednesday is the last day, right? So we're gonna skip a bunch of pages. They make you convert a lot of units, and I'm not gonna. We don't bother with it because that's not really like some of the conversions we'll do are going to be very basic. I don't worry about reviewing that. So go to page 81 and make sure you have a highlighter and pencil, and to the best of your ability follow along. I'm trying my best, but I can't do it all, okay? Well, you know what? Some of you might think I'm never going to use this again, but some of you are going to end up working in a factory. They're going to teach you way more than I'm teaching you. I'm going to give you the basics. But I worked at Kitchen Craft for 7, 8 years. So we had to measure stuff all the time. I was running machines. If you don't check your stuff, if you're producing pieces and they're off, you can get in big trouble. Like you wasting so much money. Like wood is expensive. So I had to like constantly check. So I had like a caliper. You know what a caliper is? Right? This one is a digital one. I don't think it works. But you can actually precisely measure items, right? And then it tells you here to various degrees of precision what that piece is, what the width is. So I always had to check the width of the piece, right? With one of these or a measuring tape. And so, but there's always a limit. There's always a limit to everything, guys. So if you're measuring something, you can have the most precise tool ever. At some point, did you know that at some point it's guessing? At some point, would that make sense to you? At some point it says, okay, enough, like I can't go even more accurate than this. I'm just going to tell you you're right now at 30 something millimeters. But really you can zoom in and zoom in and zoom in indefinitely, really in theory never really arriving to the smallest unit of measurement. I know it's kind of like what, right? But that's how it goes with units, right? So I will highlight a few things. In everyday life, people often use the word precise and accurate to mean the same thing. Just wait a little bit. Okay. In mathematics and in trades, however, they are different meanings. They have different meanings. Okay. Accuracy refers to the exactness of measurement. Okay. To be accurate, a measured value must be as close to the real value as possible. As close to the real value as possible. If you have measured something accurately, someone should be able to repeat it. Okay? If something is accurate, you should be able to repeat the same measurement and get the same value. That is very important for this unit. I'm going to ask you this in various ways. You should be able to repeat it and get the same value. You can box this in on the side. It's summarizing what accuracy is, how close the measured value is to the true value. So if you have a piece of lumber and you measure it, there's actually a true value, like that piece measures 45 millimeters. Whether or not you're able to measure that exact measurement with your tool, that is another problem. Accuracy can be affected by improper or careless use of the measuring device, as well as a damaged measuring device. Can you please box that in? That is very important. For example, anybody enjoy baking? You enjoy baking? Yeah. So if I fill a measuring cup with milk, right, and I put it into the bowl, and then I take that same measuring cup and get some flour, what's going to happen when I dump the flour into the bowl? What's going to happen with the measuring cup? it's going to stick. It's going to keep some of that flour behind, right? And if you keep doing that, it's actually in theory, I know when you're baking, you don't think about it that much. You're like, whatever, it's about right. But in theory, you're not using it properly because you're some of that flour is getting stuck on the sides, right? When you're measuring, I always had this problem with newbies at KitchenCraft. I had to train them. They didn't know how to properly use this thing, right? Like you have to make sure, right? Like if you measure from the edge, I would actually say don't use this little tab. You see that? You see that play there? I said don't use that. Like I would tell them, start with the one here, line that up with the piece on the edge and measure from there, right? Oops, you can't see that, right? But you have to line it up perfectly, and that's when you measure because you want it to be accurate. 1 mil off would sometimes be enough to discard that piece, right? So I tell them don't use this little tab because it over time as you keep using it, it actually wears out. Like these little tabs wear out, and then your measurements are off, right? And everything was computerized, so you had to calibrate the machine. So most of the time when I worked with a very expensive piece of equipment, I used this, right? I used the caliper to help me calibrate that machine. So careless use or damaged devices, for example, anybody done oil changes in their cars? Yeah, some of you. If you run the engine just before you're changing your oil, it's very hot, and some of the funnels, if you know what, right, a funnel could melt or it could warp, right? And some funnels are used to measure liquid as well. They have like some measurements, so that would obviously be a damaged device. Don't use it, right? It's not accurate enough, right? You know what else happened to me? You know what a jerry can is? It's the red containers to fill up fuel, gasoline. The yellow ones are diesel, right? But what happens to those things? Like they have a measuring, like if I think of my jerry can, if this is a side view, it has like markings on the side in liters, right? Well, what happens if you leave that jerry can in the shed on a really hot day? It won't melt, like it's very resistant to temperature. But anybody ever seen that it like bloats like this? Like there's so much pressure in there. Like when you open that thing, it's like right, like it decompresses. So technically, if you were to measure these lines, like if they're like this, it's not now giving you an accurate measurement, right? So that would be in a proper use of a measuring device. Like you should probably use something else to measure the amount of fuel in that jerry can. Obviously, it's just there to give you an approximate amount, but for our unit, our purposes, that would not be a proper use of the measuring device. Okay, so this is what I want you to write down. To be accurate, you need to watch out for two things, okay, moving forward. Obviously, you have to use it properly and it shouldn't be damaged. That's beside the point, right? That would be obviously something that comes before. But you need to watch for the unit, like, sorry, my bad. Standard, you want to use a standard unit of measure. What I mean by that? You want to use something like centimeters, inches, feet, degrees Celsius, centimeters cubed, kilometers. You get the picture, right? Hertz, volts, etc. So any unit that you will have heard of, if you notice, it's a standard unit. You go any country in the world, except for the US, and they will know what a centimeter is, right? Yeah, they think they're better than everybody else, and maybe they are, but standard unit of measure. And the other one is the scale. You want an appropriate scale, I should say, appropriate. So what do I mean by an appropriate scale? Would it be smart to measure the thickness of a book in kilometers? It wouldn't be a good scale. It's a terrible scale, right? It just doesn't, yeah. But that's just something that you need to watch out for, an appropriate scale. And that I'm not going to add much to it. But these two things, if you use these two things, it can be repeated. Somebody should be able to repeat it and get the exact same answer as you. Okay? What would be a non-standard unit? Something that isn't standard. It's actually standard. Anything with meters to it is standard. But if you use, for example, like if I use my arm span, what's that? Manhole covers? Okay, because it's not standard, right? Or if I use my forearm to measure something, right? And then I ask somebody else to measure that same one. Hey, use your forearms to measure this. Would the answer be the same? Probably not, right? Mine are longer than most of yours. And or thumbs or anything like that. It wouldn't be standard. Or using steps, like I don't know if you ever, like when you play a game outside, sometimes your teachers or you might be asked to like count 50 steps that way, 30 steps this way, and that's our field, right? But it wouldn't be accurate. Like somebody else would probably do it in 25 and then another person would do it in 28, right? It would depend because everybody has a different stride. Okay. Yes, just make sure you make it quick. So let's put this to the test, and then we'll do some math after this. Okay. Explain if the following measurements would be accurate. Right? Tell me. Explain if you would have an accurate measurement. Okay. So we're going to say this. Using the length of your forearm to measure the length of the picnic table. Let's talk about the unit. Is that a standard unit? Using your forearm? Not a standard unit. What about the scale? Would the scale be appropriate? Using your forearm for a picnic table? I'd say it would be okay to use, right? Is appropriate. But here's the kicker. If as soon as you have one if one of these fails, you would have to say, therefore, okay, not accurate. And this is the culprit. The unit is the culprit here. Okay, this is why can't be repeated, right? Can't be repeated by someone else. Okay, using the length of or your stride to mark off the playing field in soccer. Let's talk about the unit. Let's talk about the scale. Is the unit standard? Not standard, right? It's a stride. And the scale, you think it's appropriate to use that scale for playing field? Using your steps? I would say so, right? Like it's not unreasonable. It's not like, hey, measure the distance from here to Brandon using your strides. Go, right? Like now that's not appropriate, right? Scale. Yes, appropriate. Okay, but we still conclude therefore not accurate. And the reason is this again, right? The whichever one, if there's one not in there, then it's not going to fly. Okay, using a meter stick to calculate the distance between two cities. Let's talk about unit. Let's talk about scale of the unit. Meter stick, right? It is a standard, is standard, right? A meter stick is a meter stick. It's a meter. It doesn't matter where you go. Everybody would know this is exactly a meter. I can measure it, right? Scale, not appropriate, right? Use kilometers instead, right? Kilometers or miles, anything like that would work, okay? So there's the not right there, therefore not accurate. Is there one that's going to be accurate, Mr. Dirksen? Keep on saying. A ruler marked in millimeters to measure the width of a book. You think this is going to fly? This is standard. Standard unit, check. And appropriate scale, right? Millimeters to measure the width of a book. It's not unreasonable. Scale. Millimeters, right? Check. Therefore, is accurate. That would be an accurate representation of this. So that's all I'm going to say about this. I'm going to ask you this here, there, ACs, tests, quizzes, something like this is going to be there. You're going to have to justify based on these two things. Right? Of course, we're always assuming that it's not broken and that you're using it accordingly. Okay. All right, let's keep going. I wonder if I'm going to ask you to try it first. No, I'm not. I'm going to go straight to the math part now. Okay, come with me to page 82, bottom of page 82. And remember, I'm starting the unit, so I kind of take my time for certain things. So bear with me. Okay, like accuracy, precision is related to the exactness. Let me just get this to stay here. It's not saying, not behaving. Watch this. Just wait a little bit. I need some fellows to come back here. Precision is the smallest unit of measurement on the measuring device. Okay? Smallest unit of measure on the measuring device. And here's another one. Precision is related to the exactness. It is determined by the limitations of the measuring instrument. Okay? For example, if you're measuring the device and it's marked off in centimeters, that is as precise as you can measure. Your answer will be to the nearest centimeter. A measurement made with a ruler marked in millimeters would be more precise. So let me just show you here a quick illustration. I think I have this one here. Yeah. That's why I keep a meter stick. I used to use it for other things, but now I'm just using it for lessons, okay? I'm just kidding. Okay, so which side of this ruler would be more precise? Exemplar A or exemplar B? Did you say A just for the fun of it? B would be more precise, right? It has smaller increments, way smaller than this. Do you notice, like, what is the increment of this? Pay attention to that because I'm going to ask you this. What's the increment? Like, what's your precision of this ruler here? Notice that from here to here is a centimeter, right? So it's going up by half a centimeter. That's as precise as you can get. So this marker here, what do you think that would be? What would you say that would be? 13. If you had to pick between 13 and 13.5, you'd have to say closer to 13, right? But you're guessing. If I use the other side, now I have millimeters. Can you figure out how many millimeters that would be? It's hard to see, right? 13.2 or something like that. So you're more precise with this instrument. I hope that's starting to make sense. So precision is to the exactness. That's what it speaks to. Okay. All right, let's keep going. Because of the limited precision of a device, there's always some uncertainty. This is important. There's always some uncertainty. That's due to the limitations of the precision. Okay. If you're measuring a box with a ruler marked in centimeters and it is slightly less than 6 centimeters, you have to say that it is 6 centimeters long. You cannot give a more precise measure. This is because of the units of the measuring device. Can you write this or highlight this? Uncertainty is also known as the margin of error of a measurement device. So a measurement device can be off. It can be off. Another thing is here, uncertainty is half of the precision. Here's where I need to give you a little bit of extra notes here. The book doesn't do it, so can you write this down? State the precision and uncertainty of the following. Okay, I'm going to give you some examples. So let's say A here, something measures 6 feet and 2 inches. Let's go for B here. I give you another one here. Just write it down and then we'll solve it. 185.19 grams. C, 3.5 liters. One more. D, 173.358 millimeters. You're writing this down, right? I hope so. Okay, so you have to be detective now. You have to look backwards. What is my assumption? If I see this measurement, what am I assuming the precision of that device will be that I use to measure this thing? How precise is it? To the nearest inch. So from there, I say that the precision is 1 inch. It goes up by 1 inch at a time, right? By 1 inch at a time. And so therefore, the uncertainty I will have based on this, you just watch what it says here. Uncertainty is half of the precision. So we're going to take our precision and divide it in half. So 1 inch divided by 2. Uncertainty is, watch this, plus or minus 0.5 of an inch. I will make an arrow go from here to here. That's why we're doing that. So this is the uncertainty, that's the precision. Okay? And you're like, okay, what did you just find, Mr. Erickson? This is really what's happening here. 6 feet and 2 inches plus or minus 0.5 of an inch. This is now the measurement that we started off with its uncertainty. Guys, this is not too hard to do once you practice a few. Okay? Okay, so if somebody says, I'll be back in 5 minutes, you think they will be back in exactly 5 minutes? But they're not telling you 5 minutes plus or minus a minute or two, right? They're not saying that, but we're going to start doing that in this unit, right? So what about here? What's the precision of the measuring device that was used to measure this? And I will bring my props tomorrow to show this to you in better detail. But watch where my pencil is. You're going to focus on this last digit, and you're almost going to assume you're going to fill in zeros for everything else. And for that last digit, you're going to assume that there's a 1. And you're like, what? This doesn't make sense. What you're stating here is that the measuring device used to measure this can go up or down by 0.01 of a gram. If you put something slightly heavier on that scale that was used to measure this, it would go up to 185.20, 21, 22, 23. That's what precision is. This is how accurate that thing is, how exact it is. Do you need to do the 3 zeros here? Nope. All you need to do here is just write it like that. But I'm just trying to make a point here. So what would be the uncertainty in this case? You take that precision and you slice it in half. And what do we get? There's a pattern here, guys. 0.01 divided by 2 will be 0.005. So it's plus or minus, like it can be above or below by 0.005 of a gram. So what did you just find? You're now able to say that, hey, remember that thing that measured 185.19 grams, right? Actually, it could be over or under by this much. Do we make a big deal out of it? Probably not, but certain industries, that would be a big deal if you're off by that much. Depends on what industry you're in, right? So we figure out how precise this thing is, and then we're like, wait a minute, you could be off by a little bit. That's why we divide it in half here, and then it comes here. I will highlight after this yet, okay? Next. I'm going to pause here for a little bit and let you try this one right here. Just try this one. It should take you 2 minutes. Figure out the precision, figure out the uncertainty, and then write the measurement that we started with its uncertainty right next to it. Give it a try. And if you're like super, risk taking today, you do D as well. Okay, and then we'll be back. Sometimes it helps getting a different angle to this. When we're thinking of this here, let's say this 3.5 liters, right? Let's say it's a gas pump. You would say that what I do is I focus in on that last digit and I put a 1 in there for that as a placeholder. And then I fill everything in with zeros. So what you just found, guys, no talking now, I need to focus, right? Because I get confused too. So if this is 3.5 liters, what you're talking about is that whatever device you were using to measure this can go up by 0.1 of a liter, right? Like if you went up, you would go up by 0.1 at a time. If you were to go down, it could only go down by it could only go down by 0.1. Sorry, not 0.01, 0.1. 0.1, and then goes down by 0.1, right? Minus, minus. If you were to put a little bit more liquid into this, you'd go up by 0.1, up by 0.1. So we don't know what device was used for this. So we have to look at what number is on here. And that's where we get our precision from. So always focus on that last digit. Uncertainty is half of that. Just divide it. And did you do it already? Ready for this? 0.5, right? 0.05, sorry. That's the uncertainty. That's how much this thing can be off by. Okay. You know what the precision and uncertainty of a gas pump is? Have you ever, you guys gas up? Some of you drive. Maybe you don't gas up. Maybe somebody else does it for you. Maybe you don't care. Maybe you just go fill it up, right? Just fill it up. But it's actually three decimals. I don't know if you've ever seen the liters. It's 3 decimals. Like they're very, very precise. They want to make sure they charge you every penny, right? So that's how it goes. So we can now state the 3.5 liters up here and say, hey, it actually can be off by a little bit. And you're like, Mr. Erickson, what do we base this on? Like, how do we come up with that? Well, we first had to figure out the precision of that instrument. Like, what does it go up by? And then we're saying, hey, at some point you guess. This instrument is guessing. And it's guessing, and so we add or subtract half of the precision, which is also known as the uncertainty, to come up with that. Mind-blowing, isn't it? I think by day 3 you're going to be comfortable with this. Okay, one more. What's the precision for this fella? And so I focus on this last one. I'm going to stop there, but I'm just going to say for now, I don't care about the rest. Right? I'm just going to put zeros. But when you get to that last decimal, you put a, not an 8. That's what a lot of students do. Just put a 1. Because this is just saying, hey, I know that whatever was used to come up with this number, I know that the next one up would have been 0.359. Or one down would have been 357. That's what you figure out here. Do you think this instrument is precise? If you had to guess, I would say it's very, very precise. The more decimals you have, the more precise you are. Okay? Uncertainty, I'm now forgetting, I don't need the zeros in front, right? It's just a strategy. I'm trying to help you out here. Okay? Trying to lend you a helping hand. If you're willing to learn, you are going to learn. Okay? But I can't make you. Right? So this is your uncertainty, which is ridiculously low. It's almost like, really? You're going to worry about that, right? But in this unit, we do, right? 358, so that measurement we got in millimeters. We go plus or minus, and this is going to be tough. I'm just going to put that down here, 0.0005 millimeters. Okay, before we go, you're going to give this a try, okay? I want you to just come with me to the next page here, 83. If you are willing to learn and you're paying attention, you can actually significantly improve your mark in this course if you do well on this test. So go to page 83 here. It is often necessary to record how much uncertainty exists in a measurement. Unless stated otherwise, uncertainty is given half the precision of the measuring device. I told you that already. Okay. We're not going to talk about the box or anything like that. I want you to look at it this way. I want you to box this in. This is very important. Because so far, most of your high school or junior high career, you were just given the value, correct? This is how long something is, blah, blah, blah. Now, we're going to add or subtract the uncertainty. So this is new. Measured uncertainty can be written as follows, right? From this, guys, I think I'm going to give you these notes. I'm going to give them to you tomorrow because you don't need them for now. I want you to figure out the precision and the uncertainty of the following measurements before we go today. And if there's something you're not so sure about, try it, skip it, come back tomorrow. I will review it, okay? But before you go today, give me the precision and the uncertainty of those 4 examples, right? Thank you, guys.